What if you could treat your app's AI logic like a TV channel? Want to switch models? Want to A/B test a new feature on just 5% of your users? Want to change the system instructions to make your AI assistant friendlier? Want to A/B test a new feature on just 5% of your users? That's the power of combining Firebase AI Logic with remote config. No need to recompile your app, no need to go through a lengthy approval process, no waiting time. Instead, just instant control from the cloud at your fingertips. In this video, I'll show you how to set up everything from defining remote config parameters in the Firebase Console to fetching parameter values at application startup and even receiving feature flags in real time. The concepts in this video apply to both Android and iOS, but I'll be showing you one really cool feature that's only available on iOS. Let's see how we can remotely control our app from the cloud. You can use Firebase Remote Config to remotely configure the behavior and appearance of your mobile or server-side apps without having to ask your users to download a new version of the app. To do this, you first define configuration parameters in the Firebase Console. Configuration parameters are key value pairs that can hold booleans, numbers, strings, and even JSON objects for more complex configurations. For example, the temperature and top K parameters for a large language model. You can then retrieve these configuration parameters, for example, at application startup. When it's a convenient time, you activate the parameters in your app and apply their values. For example, if you plan to change the layout of a screen or the color of the UI, it's probably not a good idea to do this while your user is on that particular screen. That would be pretty distracting. Okay, time to look at an example. My team and I have been working on a meal planning app that uses AI to generate recipes based on a list of ingredients you provide. To help users visualize how the finished dish should look like, the app uses Gemini and Imagen models to generate a realistic picture of the recipe. These images look really good, but you might have heard there is a new image generation model. People seem to be going bananas about it, so we really want to use it in our app as well. We could replace the model name and version in the source code, but let's make sure we're prepared for the future. Changing the source code would require us to ship a new version of the app every single time we need to update the model name, and that might take too much time. So instead, we'll use remote config to allow us to remotely control the model name and version. This will allow us to make instant changes without having to redeploy the entire app. And since remote config has SDKs for iOS, Android, Flutter, Unity, C++, the web, and even offers server-side support, this model name change will seamlessly be propagated across all your apps that use remote config for managing the model name. By the way, I strongly recommend implementing this strategy to manage LLM model names, not just for Gemini. It allows you to seamlessly transition to updated model versions, for example, if the model you're currently using in your app becomes deprecated, all without having to ship a new version of your app. To remotely control the model name used in our app, the first thing we need to do is define a new parameter for the model's name in the Firebase Console. In the remote config section, make sure you select Client, as we'll be using this new parameter in our client apps. Next, create a new configuration by clicking on Create Configuration, and then type in the name for the parameter, making sure the parameter type is string. For now, let's use Gemini 2.0 Flash Preview Image Generation, as this is the model we've been using in the app so far. And don't forget to save the value and then publish the changes. The next step is to add remote config to the app and initialize it. This sample app uses a bunch of other Firebase features, so we've already added the Firebase SDK and connected it to a Firebase project. If you want to learn how to do this in your app, here is a video that walks you through the steps. Before we can import and use remote config, we need to add the library to the app's main target in Xcode. We can now import Firebase remote config and initialize a remote config instance. For production, I recommend setting the minimum fetch interval to 3600 to prevent your app from being throttled, but during development, you might want to set it to a lower value. The next step is to set the in-app default parameters. This is important to ensure the application works properly, even if the user is offline when they start the app for the first time. There are two ways for doing this. You can either define default parameters in code, or download the current version of the remote config parameters from the Firebase Console and add them to your project. Once the file is downloaded, drag the file into your Xcode project and then load it using the setDefaults method. If you'd rather define default parameters in code, here is how you can do that. We can now retrieve those parameters from remote config and apply them to the app. At the moment, this will retrieve the parameter values from the locally defined default parameters. This is great as it means the app will always be able to access those default parameters, even if the user is offline and the app cannot fetch the remote config parameters from the backend. Let's now take a look at how we can remotely change parameter values. For this, we first need to add a piece of code that fetches and activates any new or updated parameters from remote config. A good place to call this might be when the view appears, for example, inside a task view modifier. We've now got everything in place to configure the model name remotely. Let me go back to the Firebase console and update the value for the model name. I heard Gemini Nano Banana is going hot. So let me enter Gemini 2.5 Flash image preview and then publish this new value. The app will fetch new remote config values whenever the view appears, so I'll briefly switch to a different view and then come back to activate it. In Xcode's log, we can see that the new value was successfully fetched. And now, when I generate a new recipe, I will get a much better looking image. Also notice that the quality of the text is much higher. The model we used before apparently didn't quite understand that it shouldn't include the instructions from my prompt in the output. Great. So we're now able to remotely control the behavior of our app. The app picked up the new value so quickly because I set the minimum fetch interval to 0 when configuring remote config. While this is okay in development, it can result in your app's remote configuration updates being throttled. To prevent this from happening, we recommend a minimum fetch interval of 3600 to prevent this. But 3600 seconds is an entire hour, and sometimes you really might want to be able to make sure new configuration values take effect much quicker. Now, you might be tempted to implement frequent polling, but there is a much better and more efficient way. The Firebase team built real-time remote config exactly for this use case. It allows you to receive updated configuration parameters in your app the moment they are published without any inefficient polling. Here is how it works. First, you need to register a configuration update listener. This listener will be called whenever a new configuration is published. Inside the listener, you can then activate the new configuration and update the UI. Let's assume we realize the users of our app are overly excited about these new AI-generated images of their recipes and just keep on generating new recipes. To encourage power users to upgrade to the paid version of the app, we've implemented a paywall that shows up when users have exceeded the maximum number of generated recipes per day. At the moment, this is set to a pretty generous amount to 20 recipes per day. But If we realize that users are generating too many recipes, we can reduce the number of maximum recipes per day in the Firebase console, for example, to 5 recipes per users per day. Once I publish the new configuration, it will be sent to all application instances that are currently running, and the next time a user that has exceeded their daily allowance tries to generate a recipe, they will see a paywall. As you can see, remote config not only helps you keep your app up to date and healthy, even in a fast-paced environment with frequent business requirement changes, it also makes sure you can reduce risks and enforce AI safety. Let's take a look at one more thing. Let's say we want to experiment with the model parameters like temperature, top K, top P, and max output tokens. These are all parameters that belong together, so it would be nice to express this by somehow grouping them. In Swift, you typically use a struct to express that certain properties belong together. Remote config supports JSON, so we can define the model parameters using a JSON object like this. Now, thanks to the codable support in the Firebase SDK, mapping this JSON object to a Swift struct can be written as a one-liner. This is a game changer because you're fetching a complete type-safe configuration object in one go, reducing the risk of errors from managing multiple individual parameters. This also allows us to set up A/B tests for finding the best model configuration for generating delicious recipes. To learn more about setting up A/B tests, creating rollouts, and targeting, check out the remote config documentation. So, you now have the remote control for your app's AI. You've seen how easy it is to swap models and toggle features instantly. But this is just the beginning. Now that you have the fundamentals in place, you can take advantage of some of remote config's most powerful capabilities. For example, you can safely deploy new AI features with gradual rollouts. Not sure if users will like a new model? Release it to just 5% of your audience, check the results, and then confidently roll it out to 50%, 85%, and finally, to everyone. Want to know which of 2 models gives users better results? Run an A/B test and let your data decide the winner. This gives you an incredible level of control to build, test, and ship amazing new features. To learn more, be sure to check out the documentation. Thanks for watching, and I will see you in the next one.